We're at CES, and what better thing to do than talk about the weather? And we're talking to Andrea, and you have a very accurate representation of the weather because of these weather stations that are portable and go out in America's and the world's farmlands. Why don't you tell us about what we're looking at?
Sure, absolutely. So what we have here is, we call it the Arable Mark, and it works as a in-field weather station. So this goes above the crop canopy. It's solar recharged, and basically it measures humidity, relative humidity, air pressure, temperature, and it has what's called a disdrometer that's built into the top here. So as soon as a single raindrop hits the top of this, it will begin measuring frequency and intensity to give that an exact measurement of the rain that's hitting your field. So instead of relying on a weather station that's 10, 20 miles away, it allows you to actually measure what's happening directly in your field with your crop. In addition to that, we are working with government data on historical weather information as well as government forecasts, and we're helping to sort of correct the gaps in what might happen. I mean, we've all had it where you see that it's supposed to be raining and then you walk outside and it's sunny, and we're trying to figure out the gaps in that information. So we have what we call point forecasting, which is a machine-based learning where we're able to fix the gaps in forecasting and be more accurate than the information people currently have access to.
That's amazing, especially this last point about being able to improve the accuracy at a much more granular level than before. And it makes a big difference because of things like frost and so forth, right?
Yeah, so our sales team is based in California. I'm from the Central Valley, so oftentimes, especially with citrus crops, you hear about concerns about frost hitting your field. And in the event that you don't have accurate data, or maybe you spend all of this energy trying to make sure that you're turning on your fans and that you're making sure that your crop is safe, then the frost doesn't happen. So what we're trying to do is mitigate that problem by being actually accurate and telling you when those frost events are going to take place. And our historical information, working with, again, 30 years of back data, we're showing really, really successful rates of accuracy.
And so, from a cost perspective, is this going to, bankrupt a farmer? How does it work?
No, absolutely not. I mean, honestly, even not including the information associated with measuring the health and the stress of your crop, which this does through our spectrometer and net radiometer, just as a weather station, it's more affordable than a lot of the options that are out there. For our 2018 rates, basically this comes to about $1,400 collectively. So you have the hardware device, it's cellular connected, so that involves your SIM card. That together costs around $1,000, and then we have a subscription service. So basically we're offering, with all the information this is collecting, a data team that converts that information specifically to whatever crop you're working in. So if you're a citrus farmer, this information is very different than if you're a corn farmer in the Midwest. So basically we're trying to make sure that with this subscription program, you're able to make harvest management decisions, anticipation of pests and disease more accurately to your specific crop.
Well, and you touched upon it, the whole mass spectrometer. That's amazing you can put that in there. But what sort of things can you detect then?
So let's consider, for example, if we're measuring leaf moisture and leaf temperature, and we have a forecast team, like I mentioned, with point forecast that can anticipate relative humidity, we're able to actually say, I think that in 4 days' time, you're going to have an outbreak of white blight. It's time to prepare your crops. So we're making sure that we're actually giving that disease management through disease models in a really personalized way, so that farmers, instead of necessarily having to spray sort of semi-constantly to mitigate the loss of their crop, we're able to give you more detailed information to make time-based decisions.
So it not only saves them time, it saves them money in terms of fertilizer they might not need to apply or whatever, pesticides.
Yeah. I mean, we have 100 different use cases for it. We spoke with almond farmers who are worried about chilling hours, which are really important before an almond actually sort of wakes up in the spring and starts to pollinate. So what we're finding is that we can, with our weather station, measure the number of chill hours that have taken place so that we can help our growers figure out how to in the event those chill hours aren't actually reached, how to use clay foliars to make sure that their tree is tricked into thinking they've reached those chill hours. It's really a management system that they can use to change their decision making.
Excellent. Well, another interesting IoT application here.
Thanks, Andrea. Thanks so much.